This video is to help anybody who had troubles with number 12 on tonight's homework. It was quite a tricky little problem. So first of all, this very crude thing over here, there we go, sorry. My thing's not working, my stylus is not working. So this is my building, and I know that it's 60. This is just a, horizontal line from the building to the pole. This says 14 degrees because they said the angle of elevation to the top of the pole, which is over here, was 14 degrees. And then they said that the angle of elevation from the building, the bottom of the building, to the top of the pole was 28 degrees, so this angle is 28. If you draw a line from the top of the building to over here, the pole, you're going to break the pole into two pieces. And you can label those two pieces. This piece I know for sure is 60 because the building was 60. And this piece I'm labeling Y. You can give it whatever variable you want, but I don't really know this length right here. So now what I'm seeing is that if I look at this angle right here, I'm trying to find this, which I've labeled as A. I'm trying to find the distance from the building to the pole, and I've labeled that A. So if I look here, I've got this side, kind of, and I've got this side as a label. So this is the opposite side. This is the adjacent side, which means I can use the tan. So I'm setting this equation up as the tan of 28 degrees is equal to the opposite, 60 plus y, because that's the length of the entire pole, over A, the length that I'm trying to get. Now I'm going to set up a second equation because this is kind of a tricky problem. You're not just going to be able to do it in one quick step. My second equation is going to involve this triangle up, whoopsies, I did not mean to do that. This triangle up here, which I said was 14 degrees, and I know that this is Y, and again this is still A, because even though it's from the top of the building, it's still got to be the same as the bottom. So I'm going to set up a new ratio, and that's going to be that the tan of 14 degrees is equal to Y, the opposite, over A, the adjacent. Now I've got these two equations, which really means I have a system of equations, and one of the things you learn in solving systems of equations is that you can use the substitution method. So that's the method I used. And substituting means that you solve one of the equations for a letter, and then you put that value back into the other equation and finish solving. So here's what I did. Here's equation 1, and here's equation 2. The tan of 14 equals y over a. I decided to take that equation and solve it for y so that it would say y equals something. So in order to get rid of this a that I had underneath the y, because it was the tan of 14 equals y over a, I multiplied by a here on this side, which means of course I have to multiply by a here. Well, when you multiply here, these cancel because a divided by a is 1. So these are going to cancel out. What you'd really get is you'd get y over a equals a, but then for y over a divided by a is really just y times 1. And then over here, you're going to get the tan of 14 degrees times a, which I just rewrote in this to make it look like this. So now I've got this equation that y is equal to tan of 14 over a, and I'm going to take this value right here, and I'm going to plug it into where the y is on my first equation. So this is my first equation, this is my second equation. I solved my second equation so that y is the subject of the equation, y equals tan of 14 times a. Now I'm taking the tan of 14 times a, which is what y is equal to, I'm going to plug it right here where the y is. So now I have the tan of 28 equals 60 plus the tan of 14 times a. And all I did was I put in the y spot the tan of 14 times a, which I got from here. Now I divided this a and this A out, and I'm going to fix something really fast. This should not be here. There we go. So going back, I divided this A by this A, which canceled. And that left me with the tan of 28, it's still there, equals 60 over A. Because both of these things are being divided by A, I canceled this one. I'm going to go back to black. I canceled this one, but I haven't canceled this one, the 60 over A. So tan of 28 equals 60 over A, plus the tan of 14 degrees. Well, so now I'm going to get rid of the tan of 14 degrees. It's just like if you had an equation that said, I don't know, y equals 60 over A plus 15. You'd get rid of the plus 15 first. So the tan of 14 degrees is kind of like that plus 14. So I'm going to subtract that on both sides. So I'm subtracting it here and here. I already know that over here, if I subtract it, I'll get just 60 over A left. And over here, if I subtract the tan of 14 degrees, I'm going to get this value that my calculator gave me, and I want you to check that and see that you got it. All I did was I entered the tan of 28 degrees and then minus tan of 14 degrees, and the calculator said, hold on, I turned it off, second trig, tan of 28 degrees, whoops, minus trig tan of 14 degrees. I'm reading it right from the calculator. 0.2823814,288. And so that's what I had left over, is that when I subtracted, I got that 0.2823814,288. So now I'm trying to get this A gone on the 60 over A, so I'm going to multiply by A here, and these will cancel, and only 60 will be left. And I'm going to multiply by A here, and that's going to give me 0.2823814,288. A is equal to 60. I didn't have room to show you my last step. My last step would be to take this and divide by, so 0.2823814,288A, and divide by 0.2823814,288, and then divide the 60 by that as well. And I want you to do that on your calculator. I think my answer was 212.47, which I rounded because I'm pretty sure your paper said to round to the nearest tenths. So I rounded that to the nearest tenths, and I got 212.5, and that is the value of A, the distance from the building to the pole. That's it. I hope that helped you out. I'm going to make another video now because William asked about number 12. I'll post both of these on It's Learning for you.